And we talk about the basket model, which is a very important model. This is all about the probability that we're gonna use in this class. We talk about sample space. What is sample space? Sample space is all the outcomes that you can get. An event is a subset of a sample space. So for example, the chance I'm gonna get a head is a subset of the sample space because the sample space contains head and tail. We have some example about sample space. We talk about some very basic rule of the probability. Right? The first one is the additional rule for disjoint for mutually exclusive events. What is mutually exclusive event or disjoint mean? What does that mean? In the sense that you understand. Can someone tell me what do you mean by disjoint events? Yeah, what does that mean? In the sense that you understand it. Do they have intersection? No, right? So basically they have no intersection. That's all you have to know, right? You don't have to know the fancy definition. As long as you understand what does that mean, I'm okay. What does complement mean? If I say I don't get a job, what is the complement of I don't get a job? I get a job, right? The opposite of with the event, right? We talk about some example about whether are they disjoint or not. All right, so we're done there. And now we continue with 12.7, random variables. This is where most statistics students don't understand what that means. Like they just listen to stat instructors say random variable, and they don't have no idea what that means. A random variable represents the value of the variable or the characteristic of that variable before we look. What do I mean by that? Let's go back to the baskets model. If you would have randomly picked out a ball from that basket, before you look, you don't know whether it's gonna be blue or white, right? So that's probability. Once you look, it's no longer probability, right? You're gonna know whether it's blue or white, right? So the probability is gonna be either 0, if it's not blue, and 1 if it's blue, right? So the probability, if we talk about before we look into your hand, whether it's gonna be blue ball or white ball, right? Or before you flip the coin, whether it's gonna be tail or head, right? Once you flip it, you look down. When you know whether it's head or tail, there's no longer probability. So that's what random variable is. It represents the value of the variable before we look. Formally, a random variable assigns a number to each outcome of a random circumstances. For example, if I say, I want to know the probability, denote capital P, of someone, an average American who drink more than 4 glasses of water a day. Well, I don't want to write out the whole thing of average American who drink more than 4 glasses of water a day, right? Mathematicians, we use notation, right? So X represent what? An average American, right? So that's your random variable. And it assign what's value? 4 glasses of water a day. Right? So here's a random variable. Is the letter X. Maybe I do like that, so we don't have enough space. And assign is that event, that random variable being assigned to a number, which is number 4. And in context, somebody who drink more than 4 glasses of water a day. There are 2 classes of random variable that we're going to study in this class. One of them is called discrete random variable, And the other called continuous random variable. We talk about this. I just never tell you what it is. A discrete random variable is a quantitative or numeric variable that can take one of the countable list of distinct values. Right? So for example, number of phone calls you make a week, right? Number of pets you have in your house. You can only count, right? One pet, two pets, right? One phone call, two phone call. Number of shirts you have, right? So they take count values. Now, for categorical variable, also discrete random variable, I say if it's yes or no, well, I can assign 1 for yes and 0 for no, right? So it's discrete, right? You take the value 1 and 0, that's count values. If I say woman and men, again, I can assign 1 for men and 0 for women. Right? So it's kind of discrete random variable in that sense. Categorical variable, never continuous random variable. You don't have you don't assign continuous random variable to women or to men, right? You either assign them 0 or 1. And then the continuous random variable is a quantitative numeric variable. Again, only quantitative numeric variable here for continuous random variable, and discrete, take both. Right? But categorical only take discrete random variable. That can take any value in an interval or collection of intervals. We talked about this last time, about height. Let me go back up here. Well, I don't have it here because I have a new slide. Remember, when we talk about sample space, about height of a human being, right? I start at 0.2, and then the height is 2.5 meters. So again, it can take any number in the interval, right? Me, I'm tall. My height is 1.53. Right? So that means some other people will be 1.54, right? You can take any values in that interval, right? It doesn't have to be count. So that's continuous random variable. Same thing with weight. Weight is a continuous random variable, right? Times. What else? Weight times height. Temperatures. Maybe this example will help you distinguish what is discrete and what is quantitative variables. We're going to select a car from a dealership lot. And they have some characteristic. Weight of car in pounds. I don't know how much car weighs, maybe 2,000 pounds. Is it continuous or discrete? Oh, first of all, is it categorical discrete or quantitative discrete or quantitative continuous? Is it categorical? Weight. No, right? It's numeric. Discrete or continuous? Continuous, right? I just said earlier, right? Continuous. So continuous. I would have said quantitative continuous. Even though if you say continuous, I still give you full point because the only variable that be able to be continuous is quantitative. Number of seats. Small sedan will have roughly 4.5 seat, right? 4 seat. Minivan will be 5 or 7 feet a seat, right? So this is going to be quantitative things you can count, right? Quantitative discrete. Overall condition of a car. I'm going to assign number 1 if it's good. Number 2 if it's very good. Number 3 if it's excellent. First of all, is it discrete? Is it categorical or numeric or quantitative? I know it's confused. Like I see two things. I see both, right? It looks like categorical for me, but then I see number one. I see number two. Well, it's just assign number to characteristic. It's kind of like Jersey's number, right? It's a number, but it doesn't mean anything if you average them out, right? It just assign a number to a person. That's all. So it's zero categorical. So this will be discrete. Be discrete categorical. Remember, categorical can only take discrete random variable. Right? Categorical. Length of cars in feet. Like I said, height, weight, times, temperatures, they all quantitative continuous. So that's the example between discrete random variable and continuous random variable. Now, what is the distribution of a random variables? Right. We're gonna take a look at models. And what is model? Model is show the value that are possible for the random variable and how often those values are expected to be occurred, meaning their probability. We've done this before, we just don't know what it is. On your exam one, you've done that in your exam one. We can express a model as a function, right? Think about when you smooth out a histogram, right, into a density curve, that's a function. Or you can do table, like we did in example of, Canadian, English speaking Canadian and French speaking Canadian earlier. So that table, right? And the table show you the probability of each event. Or you can do picture, depend on what type. For example, on your exam one, you did that uniform distribution, that's pictures, right? So random variables divide into two types. Either you have discrete random variables or continuous random variable. For the discrete, we're going to talk about binomial random variable. We're going to have a whole chapter, whole two lecture about this. 201. 2, right? Very important. There's other discrete random variable as well, like the negative binomial, geometric distribution, but we're not going to go through that. The only discrete random variable we're going to talk about this class is binomial. And then continuous. Normal. The normal curve you've been doing, that's continuous random variable. The box like the box one, the rectangular one, that we can find the area under the curve easily by doing what length time width. And then there's more to come, like t distribution, chi-square distribution, which is we're not going to do in this class, but we're going to do t distribution. So far, you've been introduced with uniform and normal distribution. Binomial will be later. All right, let's talk about discrete random variable first. A probability model with a finite sample space is called finite, meaning it take the value, countable value, say number of pets you have in your house, right? Number of hoodie you got, right? And each of those events gonna take the probability between the value between 0 and 1, and all of them add up should be equal to 1. So take a look at the example, how many cups of coffee you drink here. This model represent as a table. Remember I said function table or picture? The top row will be the number of coffee an average American would drink. And the second row, the last row will be the probability. Right? So say the probability of 0 American drinking a coffee will be 36%. Right? A probability of 1 American drinking coffee per day. How many cups of coffee? Yeah, 1 cup of coffee per day will be 26%, etc. Right? From the table, I can ask you a bunch of questions. Let's verify that this is a valid finite probability model. Remember the definition of finite probability model. I mean what? The probability is, each of the probability is take a 0 between 0 and 1, take a value between 0 and 1, which is they are, right? And the add up had to be, if you add them up, had to be what? Exactly 1. So let's add them all up to see. 0.36 plus 0.26 plus 0.919 plus 0.08 plus 0.11 equal 1. So your conclusion will be yes. This is a valid finite probability model. Probability. Describe the event x less than 4 in English. Well, you're going to go back to the context. Let's talk about the context. Choose an adult age 18 or over in United States at random and ask how many cups of coffee do you drink on average per day? Call the response X for sure. So X less than 4 meaning what? In context, what would you say? Somebody drink less? Go ahead. You guys have a question or you? Okay. So somebody drinking less than 4 cups of coffee per day, right? And that somebody will be who? An American who age 18 and over, right? So in context, we would say X less than 4, meaning in English will be a randomly selected US adult or 18 plus who drink less than 4 cups of coffee per day. Do you guys drink coffee? I couldn't tolerate it. I like it. It just whenever I drink it, I just turn shaky. Just my I'm lightweight, so I guess I couldn't handle it. So that's X less than 4. What about P of X less than 4? And the same thing, all you have to do is what? Turn that into a probability, right? So pretty much the same thing. P of X less than 4 is a probability, basically is the probability of a randomly selected US adult 18 plus who drinks less than 4 cups of coffee per day. Like, all you have to add is the probability of coffee. A randomly selected US adult. Yes, that. So that's from math to English. Now we're gonna do backwards. Now I give you English, you're gonna translate in math to math. Express the event, have at least 1 cup of coffee on average day. In terms of X. Well, X is a randomly selected US person, 18 or over, right, who drink coffee. So at least mean what? It's gonna be greater than or less than, greater than equal to, less than equal to. At least what is this what is the direction of my inequality? If I say you drink at least 2 cups of water a day, it means what? Either you drink 2 cups, 3 cups, right, 4 cups. So the direction will be greater or equal to, right? So X is at least 1 cup. So X is greater or equal to 1. And then if I want to turn this into probability, what is the probability of this event? Well, all you have to do is add a little capital P in front of it. That's all. Right, so P of X greater or equal to 1. Now, because this is discrete probability, sometimes I call this a stick probability. Because you can put it in the stick. The probability of someone drink more than 1 cup of coffee per day is equal to the probability of that person, that randomly selected person, drink one cup, right? Or that person can drink 2 cups per day, right? Plus P of X 3 cups. Should I stop? Or... So this is 0 cup, but we start at 1 cup, right? And 2 cup, 3 cup, and then one more, right? P of plus P of X is 4 or more. I'm just rewriting what the problem tells me to write. And again, I can express this in using the stick. Let's start with 0. We don't go negative because it's countable. It's a random variable, right? We start with 0. So and then we have 1, we have 2 cup, we have 3 cup, and 4 cup, and 5 cup, etc. So at least 1 will be start from here. And then somebody is drinking it 2 cups, right? Or 3 cup, or 4 cup, or more. Let's calculate what is the probability of this event. Let's calculate it out in number. What's P of X equal 1? If you look at the table, remember, second one is the probability. P of X equal 1 would be what? 0.26. So 0.26 plus P of X equal 2, 0.19, plus P of X equal 3, 0.08, and plus P of 4 or more, 0.11. Maybe I should do it red. If you add all that up, it's gonna be equal to what's 4? Can you do something like this on the exam? Easy. Right? The math is very easy. What important that you understand the question. For this class, math is very basic. So that is an example of a discrete random variable. Next, we're going to move on to continuous probability models. Remember, the continuous random variable include in this class is to be uniform, right? Uniform, the box 1. Normal, so far, so 2. The difference between discrete probability and continuous probability is that discrete probability, I'm going to draw my probability in a stick yard like that. Right? I'm going to pick count values. I don't care what between 0 and 1, between 1 and 2, between 2 and 3, right? I don't care. I only care about the countable number. Now, continuous probability is different. You're going to scan everything from left to right. It's the model that assigns the probability as area under the density curve. Right? That's why it's continuous. You take everything in that interval. Some of them we already know. Uniform distribution have this notation: uniform, parenthesis a comma b. And someone remind me, what is the distribution of a normal random variable? What should I fill in those two empty space? Either you know you don't want to say, or you don't know, which makes me very nervous. What is this here? Notation, not number. We don't know number. What notation wise? Mu, comma, sigma. What mu means? What is mu represent? What kind of mean? Sample or population? If you forgot, think population, think Greek, right? If you see some weird notation, it's gotta be population. Right? Because usually population is unknown, right? And Greek is mysterious. Right? So it makes sense. So pop mean. And what does sigma stand for? Yeah, population standard deviation. I see why a lot of people don't like statistics. This is just scratching the surface. Right? There's more to it. All right, let's take a look at this probability, the uniform distribution. Below is a model for the random variable x, which represent the waiting time in minutes to be served at the daily. What is the appropriate distribution with corresponding parameters? We did this on your exam 1. So what is the appropriate distribution should I write here? What should I put in there? AB, right? What's my A? You forgot all of that. 10, right? Thank you. 10. And then B will be 20. 15 is your expected values, right? Your average. Remember expected value. Let me recall. Expected value denote capital E of X. Expected value of a random variable X is the unbiased estimator, so it's equal to the population mean. It's equal to, in this case, will be what? The average of AB. So on your exam 1, I literally give you the expected value. All you have to do is to come up with the work. Right? Most of you did, well, half of you did. Half of you didn't. So that's 15 right there. What is the probability that a randomly selected customer waited at least 16 minutes? Well, wait at 16 minutes. Say, for example, say 16 minutes is right here. Because it's at least, do I shade it to the left or shade it to the right? At least tell me shade it to the left or shade it to the right. To the right, right? At least. So at least 16 minutes will be 16 minutes, 17 minutes, 18 minutes. Okay. Well, this is the rectangular probability, so easy for you, right? All you have to do is find the width and the length and multiply them together. So P of X is 8 greater or equal to 16. On the exam, I do want you to write like that. My width will be 20 minus 16, which is 4. What is my height? My height is my density function right there, 0.1. Do you remember how to get that 0.1? B minus A, 1 over 20 minus 10, which is 1 over 10. Times 1 over 10, which is 4. Or 40%. Either or, I'll take both. Let me ask you a question. What is the probability of someone who drink less than, I'm sorry, who drink, I still remember the previous example. What is the probability of a randomly selected customer waiting less than 15 minutes? You don't have to use a formula or anything. What is the probability of a randomly selected customer who wait less than 15 minutes? Remember, 15 is the middle values, right? You divide the rectangle into 2 halves, so 50-50. Or you can use a formula. All right, so that is uniform distribution. Let me give you another example. Since you guys are a little rusty about this. And I want you to do this. Let me take a look at my exam. Can practice. Hmm. Here you go. Say I have this triangle. It's the symmetric triangle. It's isosceles, is that what they call it? I forgot the name. Just imagine is the left half equal to the right half. Okay, I know it doesn't look big. perfectly equal, but just imagine the equal. One, 0, 2, 5, 5. All right, now the question. I want you to find the probability, part A. I want you to find the probability of x. X represent the area of the triangle. X less than 1. That should be easy. I want you to find the probability of x less than a quarter. Let me give you a little hint. The area of a triangle is going to be 1/2 base times height. In this case, the height is 2. So there's so 1/2 times 2. The height is 1. The base is 2, which is 1. All right. So that's your little hint. I'll give you guys 5 minutes or 10 minutes to work on this. So the probability of x less than 0.5. I'm sorry, not a quarter. Anybody have an answer for part B? I'll tell you what, for this problem, you don't have to use the formula at all. Just use your common sense. What is the probability of x less than 1? So that's area right there. 0.5. Or you can use the formula. Let's use the formula. Explain. I'm gonna say explain. This is extra stuff. So area will be what? 1/2 times. What is my base here? Base is 1. Right? The base is 1. And the height is also 1. So 1/2 times 1 times 1, which is 1/2, which is 0.5. What is the probability of x less than half? Less than half will be right here. Remember, probability is represent the area under the curve. Kind of like calculus. When I say integral, means area under the curve. What is that? So we have to use formula. 1/2 base times height. What is my base? Half, right? My base half. The base half. Yeah. I'm gonna say 0.5 here. Right, that's the base. That's the base. And the height is this one. There's another 0.5, right? Because this is a isosceles triangle. Cut this part right here in half, so that's 0.5. 0.5 times 0.5 divided by 2. 0.125. I hope you guys get a little bit of feel a little bit better about continuous using geometry. Continuous random variable. Which one for you easier? Is discrete easier or continuous so far? Discrete, right? Because discrete, you given table, all you have to do, eyeball the table, you tell me, right? If they ask you what is the probability of x equal 1, 0.26, right? What is the probability of x is less than 2? X is less than 2 will be 1 and 0. All you have add them together. Right? So discrete is easier in this class so far. All right, last one. The Walking Dead. Do you guys watch The Walking Dead? Yeah, I watched the first season and then that's it. Too long. But it was good. I like the first season. The television series The Walking Dead is an American post-apocalyptic horror drama that is based on a comic book series by the same name. The first episode aired back in October 2010 and earned 25% audience share. That's a lot. That is 25% of all TVs in use during the showtime period were tuned to a station airing The Walking Dead. Let's represent the number of people who watched The Walking Dead in a random sample of 500 people who watched the TV during the time period when the show aired. The distribution had the mean 125, and standard deviation is 10. 125 people, right? Standard deviation is 10 people. Find the approximate probability that fewer than 220 people select watching The Walking Dead. I'll let you sunk in the problem, just understand what is we're talking about. Now, let me ask you a question. It is a forget about the normal thing up there. If you were given this context and you read it, is this a normal distribution? Can you tell this is a normal distribution? Is there anything that indicate this is a normal distribution? No, right? I didn't say anything about normal, right? I say mean and standard deviation, but any distribution have a mean and standard deviation, right? Even the uniform. So reading this, if I didn't say anything about normal, you should not draw a normal curve, right? Don't assume it's normal. It had to be said. On exam, I'll be very clear. If it's normal, I'll say normal. Let's just say this is a normal distribution. So normal distribution written like this, and mu will be 125. And then sigma, which is standard deviation, which is 10. So my mu is in the middle right there, 125. What is the approximate probability that fewer than 220 people select watching The Walking Dead? So 220, I would say right here, maybe I'll put it right there. It doesn't matter where you put, as long as it's larger than 125. This 125 is the middle values. The area on the left and the area on the right equal to each other, which is equal to 50%, right? So if I asked you to find the probability of less than 220, less than, you're gonna shade everything from left up to 220. your probability that you found should be greater than what? 50%, right? Which makes sense. So that's the logic. Let's found the exact value. Do you guys remember how do I do this? I had to transform into standard score, right? Standardize it. So if I would standardize this, I draw another curve. Now my standard curve will be have the mean will be 0 and standard deviation will be 1. So 0 in the middle right there. And I have to find what? I have to find the z-score. The x-axis on the standardized curve will be z-score, where the x-axis on the regular curve will be the number of people who watch The Walking Dead. Remember the formula? Remember the formula? Z equal, you standardize it, and Z equal x minus mu divided by sigma. Can someone tell me what is x? Yeah, x is your random variable, which is 220. Thank you. So 220 minus mu, which is 125, divided by sigma, which is 10. Wow, 9.5. If you look up the table, what do you conclude? You don't have 9.5 in your table, but what do you conclude? The probability is close to 1, right? Right. Because at 3 point something, it's already 9.9999 something, right? So if at 9.5 is it's pretty cover everything in the curve. So this implies the probability of x is somebody watching The Walking Dead. I'm sorry. The probability is that fewer than 220 people watch The Walking Dead is 1. Approximately. In mathematics, approximately 1, but in practical, 1. A bonus question. If you answer it right, 1 point on your exam. And write on the piece of paper with your name is, give it to me. Actually, no. Don't give it to me. Here. I'll give you the question. And then what I'm going to do is I'm going to create a little quiz on the Moodle. I'm trying to do something that is, I don't have to. Yeah, just put it right on the piece of paper and give it to me with your name on it. So same problem. I want you to find the probability that x is greater or equal to 220.